Hello everyone and welcome back. Now today we are going to learn a very important topic on linear algebra which is linear span. So इसका जो importance है वो बहुत ही ज़्यादा है क्योंकि हमारा जो next lecture होगा on basis and dimension. And basis and dimension is a very important topic on linear algebra. Almost in every exam we will see some questions from basis and dimension. But without understanding linear span we cannot understand बेसिस एंड डायमेंशन. सो इसीलिए लीनियर स्पैन को हमें ध्यान से समझना होगा. नाउ लेट्स गेट स्टार्टेड. नाउ इनिशियली वी हैव टू टेक ए वेक्टर स्पेस V ऑफ f. तो यहाँ पे V ऑफ f जो है एक वेक्टर स्पेस है एंड देन S इज ए नॉन एम्प्टी सबसेट. सो नॉन एम्प्टी मीन्स एटलीस्ट देयर इज वन एलिमेंट इन द सेट S. ओके, सो फर्स्ट V ऑफ f इज ए वेक्टर स्पेस. दिस इज ए वेक्टर स्पेस. Here f is the field and V is the set of vectors. Now after that then the set of, okay, this line is very important, then the set of all finite linear combinations. Okay, so we know what is linear combination. Linear combination means is a combination of scalar and vector like a1 v1 plus a2 v2 plus an vn. Okay, so such type of elements are called linear combination. But here a word है which is finite linear combination of elements of S. Now the thing is that S is non-empty, but is S finite or infinite? So S can be finite or can be infinite. तो उसमें यहाँ पे कुछ problem नहीं है. S में finite number of element भी रह सकता है या तो infinite number of element भी रह सकता है. But whenever we take some element from S, those number of elements should be finite. तो कैपिटल S से हमें finite number of element लेना है, 1, 2, okay, जो भी हो, the number should be finite. So take some element from S, finite element from S, make a combination and put that particular combination in a new set. That particular new set is called what? Linear span, and it is denoted by what? L of S. So that means L of S is a set. तो ये एक सेट होगा, नया सेट होगा. इसमें क्या रहेगा? L of S में क्या रहेगा? और या तो L of S का जो एलिमेंट्स है, what are those elements? The elements of L of S are nothing but finite linear combination. Okay? Suppose मान लीजिए in L of S we have a element V. Okay? V. So that means ये जो V है, this particular element V must be a linear combination of elements of S. So इसका जो फॉर्म होगा it will be like this: a1 v1 plus a2 v2 then plus an vn. Okay, an vn. So these ai's means a1 a2 a2 an, these are all scalars. So scalars will come from what? Field. And then vi's, these vi's will come from the set S. And n, what is the total number of element? N is what? Finite. So n can be 1, n can be 2, but it should be finite. तो what is L of S? तो हमें पहले क्या करना होगा? एक नॉन एम्प्टी सेट लेना है, उसमें से कुछ फाइनाइट एलिमेंट लेना होगा, फाइनाइट एलिमेंट का एक कॉम्बिनेशन बनाना है. दैट पर्टिकुलर कॉम्बिनेशन विल पुट इन ए सेट दैट इज लीनियर स्पैन. सो लाइक दिस वी कैन टेक एनी नंबर ऑफ एलिमेंट एनी टाइम्स. First, suppose we take one element, make a combination, put it in L of S. Then you take two elements, again make a different combination, then put in L of S. Again you take some more element and make another combination and put it in L of S. So L of S, in L of S there will be so many elements. Okay, L of S में बहुत सारे element रह सकता है, but all the elements are what? Linear combination. Generally क्या होता है? In one set we have some element. But in linear span, all the elements are one combination. Okay. Now let us come to the example. Now here one set is given. Now you see in this particular set, two elements are given. This is the first element and this one is the second element. Only two elements are given. And यहाँ पे जो vector space है वो क्या है? R square of R. So this is our field. Okay. Here field is real number. And the vector space is R square. R square means all two-dimensional element will come. Pair with pair. Like this 1, 4. 1, 4 is a ordered pair. So this particular element will come from R square. Show that there is one more element, 2, 3. सो 2,3 जो एलिमेंट है ना 2,3 किसका एलिमेंट है, आर स्क्वायर का एलिमेंट है. सो वी हैव टू शो दैट दिस पर्टिकुलर एलिमेंट 2, 3 बिलोंग्स टू व्हाट, एल ऑफ एस. तो हमें ये मतलब ध्यान में रखना है एल ऑफ एस में किस टाइप का एलिमेंट रहता है. सो इन एल ऑफ एस वी हैव लीनियर कॉम्बिनेशन. तो अगर 2,3 को एल ऑफ एस में आना है, ओके, सो इफ 2,3 बिलोंग्स टू एल ऑफ एस, तो 2,3 मस्ट बी ए लीनियर कॉम्बिनेशन ऑफ एलिमेंट्स ऑफ व्हाट, एस, फाइनाइट लीनियर कॉम्बिनेशन ऑफ एलिमेंट्स ऑफ एस. तो यहाँ पे कैपिटल एस में 2 ही एलिमेंट है, तो ऑब्वियसली हम लोग जो वहाँ से एलिमेंट लेंगे तो फाइनाइट ही होगा. ठीक है, आइदर हमें क्या करना है, एक एलिमेंट लेना है, नहीं तो 2 एलिमेंट लेना है. सो 2 इज ए फाइनाइट नंबर. तो यहाँ पे उस फाइनाइट का मतलब टेंशन नहीं है. बट व्हाट टू शो, इफ वी वांट टू शो दैट 2,3 इज बिलोंग्स टू एल ऑफ एस, सो हमें दिखाना होगा 2,3 इज ए लीनियर कॉम्बिनेशन ऑफ एलिमेंट्स ऑफ एस. सो to show that 2,3 belongs to what, L of s. That is 2,3 is a finite linear combination of elements of S. Okay, so there should be a finite linear combination of elements of S. तो हमें क्या करना होगा, सपोज मान लीजिए this particular 2, 3 can be expressed, okay, suppose a1 into 1, 4 and a2 into 1, 4. Suppose we can express. So after seeing this relation, you see left hand side is 2,3 and right hand side is what, a1 into, if we suppose that this element is v1 and this element is what, v2, then this is a1 v1 plus a2 v2. Now most of you may think that we have to show that this is a linear combination, but यहाँ पे हम लोग उसको पकड़ लिया जाए, मतलब suppose ये linear combination है, but yeah, we have expressed it, but we don't know the value of a1 and a2. Now our aim is to find the value of a1 and a2. So a1 और a2 क्या है, scalar. यहाँ पे जो field है वो क्या है, r. Okay, this is the field. Now if we can show that a1 and a2 are real number, तो उसका मतलब है whatever combination we are choosing here, that is correct. तो यहाँ पे हम लोग ले लिए हैं, suppose 2,3 can be expressed as a linear combination of 1, 4 and 0, 3. So 1, 4 and 0, 3 are elements of what, S. Now a1 into, so if we multiply 1 and 4 with a1, so what is the element, first is a1, then 4a1, just simply multiply it. Then a2 into 0, a2 into 0 is 0, then 3a2. Now if we combine them, first element is a1 plus 0, a1 plus 0 is a1, and then 4a1 plus 3a2, 4a1 plus 3a2. Okay, so what is our left hand side, our left hand side is 2,3. Okay, so what to show, we have to show that 2, 3 is a linear combination of 1, 4 and 0, 3. So here to make when you make the linear combination, we have two unknown, a1 and a2. So the prime motive is we have to find the value of a1 and a2. And when you find the value of a1 and a2, if a1 and a2 belongs to R, means real number, that means equation 1 is correct. That means we can express. Now if you compare both sides, see first element is 2, here the first element is a1. So directly 2 equals to a1, first value is coming. Then second equation is 3 equals to 4a1 plus 3a2. Now a1, we know a1 is 2, so it's 8 plus 3a2. So when we calculate, the value of a2 will be is 3 minus 5 minus 5 by 3. Now you see the values of a1 and a2. Our a1 is 2 and what, a2 is what, minus 5 by 3. So that means both are real. So therefore equation 1 implies 2, 3 is equals to a1. a1 means 2. 2 into 1 comma 4. Then minus 5 by 3 into 0 comma 3. So it's a linear combination. These two elements are elements of S, and this 2 is a1 and this is what, a2. So left hand side is what, 2 comma 3. So 2 comma 3 is a linear combination of elements of S. So अगर एक element linear combination of elements of S है, so then this particular element will belongs to what, L of S. It's very simple. Okay, so if one element can be expressed as linear combination of elements of S, then that particular element will come to L of S. Okay, now let us take one more problem. Now here the vector space is different. You see R to the power 4 means all 4-dimensional element, and the field is again what? Field is again R, but the vector space is R to the power 4. Here also in the set S we have two elements. So this element is V1 and this element is what? V2. Find L of S. Okay, linear combination दिखाना है, sorry linear span को निकालना है यहाँ पे. जो last problem था, in the last problem we have expressed that one particular element belongs to L of S. वो जो element था 2, 3 वो L of S का element है, लेकिन यहाँ पे हमें पूरा L of S निकालना है. So definition में थोड़ा देखिए, what is L of S? L of S में क्या रहता है? All linear combination. What kind of linear combination? Those linear combination which can be expressed as a finite linear combination of elements of what? S. Okay, so हमें L of S जो है, L of S में हमें एलिमेंट लाना है, ठीक है. सो L of S में किस टाइप का एलिमेंट रहेगा? नाउ L of S लीनियर स्पैन इज ऑलवेज सबसेट ऑफ द वेक्टर स्पेस. अगर कैपिटल V में 4x4 एलिमेंट है, मतलब R to the power 4 है ना, R to the power 4 मतलब one element is 4-dimensional. If capital V is 4-dimensional, तो उसका जो सबसेट होगा ना L of S, उसमें भी मतलब एक एलिमेंट में क्या रहेगा? 4 कंपोनेंट रहेगा. So if capital V is 4-dimensional, then L of S is also 4-dimensional. तो हमें जो भी एलिमेंट मिलना है inside L of S, those elements are what? 4-dimensional. Like second dimension means what? 2 element comes together. 3 dimension means 3 element come together. So if it is power 4, that means one element consists of 4 different components. So let A1, A2, A3 and A4 belongs to L of S. इस टाइप का एलिमेंट L of S में रहेगा. Now when this particular element belongs to L of S, okay, A1, A2, A3, A4. Now if this particular element comes to L of S, that means suppose ये मान लीजिए this particular element is V, okay, V equals to this. Now if V belongs to L of S, that means V must be a linear combination of elements of S. तो उसको जो S का जो एलिमेंट है उसका linear combination में आना चाहिए. Okay, so therefore such that, so first what we'll do, like last problem, we'll suppose that we can express, हमें express मतलब हम लोग express कर सकते हैं. Let us suppose that we can express, then we find the values of the constants. So suppose V equals to alpha V1 plus beta V2. Okay, जो alpha and beta है इसका वैल्यू हमें निकालना है. अगर alpha and beta both belongs to this R, that means we can express small v in terms of V1 and V2. So our V is what? A1, A2, A3 and then A4. Alpha into our V is 2, 0, 0, 1. Beta into it's how much? -1, 0, 1 and then 0. So now we'll write or we'll combine them. First element is 2 alpha. Here the first element is minus beta. Okay, minus beta. Then second element alpha into 0. Alpha into 0 is 0. Here beta into 0. So second element is 0. Then alpha into 0 is 0. Beta into 1. So only beta will come. And then alpha into 1. Beta into 0. Only alpha will come. Now if you compare, then our A1 is how much? 2 alpha minus beta. A2 is 0. A3 is how much? A3 is beta. And A4 is how much? Alpha. Okay. Now see what is alpha 1, A1, A2, A3, A4. You see A1, A2, A3, A4 is an element of what? L of S. So अभी हमें यहाँ पे A1, A2, A3 और A4 का वैल्यू मिल गया. So therefore what is the new form of V? A1. A1 means 2 alpha minus beta. Then A2 is 0. A3 is beta and then alpha. So this particular element will belongs to what? L of S, because it is a linear combination. Okay, and जो यहाँ पे जो alpha beta है, this alpha and beta are from the field F, sorry field what R. तो हमें पहले क्या करना है, एक एलिमेंट लेना है, उस पर्टिकुलर एलिमेंट को S का जो एलिमेंट है with the element of S we have to write in linear combination. Then after calculation we have to find the value of A1, A2, A3 and what? A4. So these all values are real number, क्योंकि यहाँ पे अल्फा और बीटा क्या था? रियल नंबर था. So 2 alpha minus beta is a real number. This is so 0 is a real number, beta is a real number and alpha is a real number. So now what to find L of S? तो यहाँ पे जो L of S है ना, L of S का जो एलिमेंट्स होगा वो इस पैटर्न में आएगा. 2 alpha minus beta 0, then beta and alpha. Suppose this is not necessary. Suppose हमें alpha equals to 1 लेना है और suppose beta equals to 2 लेना है. So both the elements are real number. Then what is the element? V will be what? It's 2 minus 2, 0, 0, 2 and then 1. So this is an element of L of S. So like this there will be so many other elements in L of S. But the L of S is of this particular form. So therefore the linear span will be like this. 2 alpha minus beta, 0, beta and then alpha, such that alpha and beta both are what? Real number. Okay, so the problems are very simple, but in basis and dimension we'll do some more different type of problem. So here in this particular lecture just we learn what is linear span and how to find the linear span, or can this particular element belongs to L of S or not. So those type of elements we learn here. Okay, so I hope you understand this particular lecture. So if you understand, then kindly subscribe and share with your friends so that the other can also learn. And thank you for watching the complete video.